Hello everyone. Today I have delivered lecture on mineralogy of the earth and geothermal gradient of the different layers of the earth. Okay, mineralogy of the earth and different geothermal gradient of the different layer of the earth. You know, earth has been divided into three different layers: crust, mantle and core. Crust is uppermost part of the earth. The thickness of the crust are vary from place to place. The average thickness of the crust is from 0 to 40 km. Then another one layer is mantle. The mantle again divided into two different layers, upper mantle and lower mantle. The upper mantle means just below the crust. It starts from 40 km and it's up to the 420 km. That is the upper mantle. The upper mantle and crust is separated by the one of the discontinuity is called as Mineralogy discontinuity. And then start the lower mantle. The lower mantle has started at 520 km up to the 2900 km. And this upper mantle and lower mantle is separated by the particular discontinuity is called as Gutenberg discontinuity. Okay. Then the mantle and core is separated by the particular discontinuity is called as Conrad discontinuity, which is present at 2900 km just below the surface. Okay, means the crust and the mantle and core is separated by the Conrad discontinuity at 2900 km from the surface. Then the core again divided into the two portions, the outer core and inner core. Outer core means outer part of the core and inner core means central part of the earth. The outer core is from 2900 up to the 5120 km, and then start the inner core. Inner core means just central portion, central part of the earth. That is start from 5120 km up to the exact center point of the earth, that is approximately at 6371 km. This is the thickness and various layers of the earth: crust, mantle and core. Chemically, these layers again differentiate. The crust is mostly made up of silica and aluminium, and mantle is mostly made up of nickel and iron, and core is mostly made up of iron and nickel and cobalt. Okay, these are the chemistry of these different layers. Now we go to the point mineralogy of the earth and its core. We are now going to change direction a little. We have been studied the scientific background required to understand the minerals present in a different portion of the earth. Things like what are the chemical bonds and how they form, what does the resulting arrangement of atoms in a mineral look like, how do we identify a mineral. Now we will apply the scientific background to the individual phases that makes up the bulk composition of the earth. You see this figure. This is the figure of the internal structure of the earth. This is the crust. The blue color indicates the crust portion of the earth. This is the one quadrant of the earth. Just 0 to 40 km showing in the blue color, that is the crust. Then this is the shallow mantle. Shallow mantle means very less depth mantle, which is indicated in a green color diagram, and very dark green color is a boundary between lower mantle and upper mantle. And then start the lower mantle. This is the transition zone of the crust and mantle. Then this is the red color indicates the total lower mantle. It is start from 520 to 2900 km, and just between the orange color shades showing the discontinuity between the core and mantle, which is start from 2700 to 2819, means approximately 2900 km. The orange color shade indicates the discontinuity, Gutenberg discontinuity, which is present at this ranges. Okay, and this lemon color shows as outer core. It is totally made up of molten magma, means liquidous material. The outer core mostly made up of liquidous material. And this is the yellow color, dark yellow color shows inner core. It is from 5150 to 6371 km. Okay, this is the Earth model, preliminary reference Earth model frame, preliminary reference Earth model of compressional velocity and shear velocity and density as function depth in the Earth. This is the difference diagram, density of the Earth. You know, density of the Earth is also increases with the depth. Suppose this is the depth on x-axis and on y-axis, the velocity or density per gram per centimeter cubic. You see this diagram. This is the crust, mantle and core, and this is the inner core. X-axis, on x-axis depth kilometer, and on y-axis velocity kilometer per second, and density of the earth material, which is given in the gram per centimeter cubic. Okay. In crust, the density is varied from 0 to 3 gram per centimeter cubic, and then it increases with the depth. Okay. You see the lower mantle is mantle. This is the mantle from 3 to 6 gram per centimeter cubic. Also in core, the density is also increases up to the 9 gram per centimeter cubic. Okay, means all the velocity of the velocity and density of the earth material is increases with the depth. Okay, I already discussed about the crust, mantle and core in details. This is the mineralogy of the different regions. The presence of minerals means mineralogy of the different layers of the earth. First we started from the bottom. You see this table. At the bottom, the crustal average composition. The average depth of the crust is 40 km, and this crust is mostly made up of feldspar and quartz bearing minerals. Quartz and feldspar content is more than that of the minerals in the crust. And considering upper mantle, which is start from 40 km up to the exact 510 km, upper mantle is mostly composed of albumin, pyroxene, garnet and spinel group of minerals. These four minerals are mostly found in the upper mantle: albumin, pyroxene, garnet and spinel. These are all the mafic minerals because of these minerals are mostly composed of mafic type of elements like ferromagnesium mineral called as mafic mineral, and crust is mainly made up of felsic mineral or phemic mineral. Phemic means or felsic means those minerals are higher amount of silica and feldspar content called as felsic mineral like quartz and feldspar. Means crust is made up of, the mineralogy of the crust is feldspar and quartz, and mineralogy of the upper mantle is albumin, pyroxene, garnet and spinel. And transition zone. What is meant by transition zone? Transition zone means those zones are separated the mantle from the upper mantle from the lower mantle called as transition zone, and in these transition zones are varies from 410 to 670 km, and it is mostly consisting of structures with both silica and silica group minerals, and majority in the garnet. Majority of the garnet are present in this transition zone. And another is lower mantle. The lower mantle is exactly started at 670 km up to the 2891 km, means approximately 2900 km. And this lower mantle is mostly made up of magnesiosite, then bismanite and stishovite minerals. Okay, and core. The core has been divided into two layers, outer core and inner core. The outer core starts from approximately 2891 km up to the 5150 km, and these zones are mostly made up of liquid composition of iron. And another is inner core, which is started from 5150 km up to the radius of the earth, and it is mainly composed of SCP iron. Okay, these are the mineralogy of the different layers of the earth crust, mantle, lower mantle, inner core and outer core. Okay, means crust is mostly made up of felsic mineral. Clearly idea about Means it is very easy to identify. The crust is mostly made up of felsic mineral like silica and feldspar, because of crust is mainly made up of silica aluminum and silica magnesium mineral, and upper mantle is mostly made up of mafic mineral like olivine, pyroxene, garnet and spanel, and transition zone between the lower mantle and upper mantle is mostly made up of garnet type of minerals, silicon tetrahedron minerals. Those minerals are belongs to the tetrahedron of silicates. Tetrahedron of silicates like garnet and olivine, and lower mantle is mostly made up of magnesioviscite, bismanite and stishovite types of minerals, and inner core is mostly made up of outer core mostly made up of liquid type of material of iron bearing minerals, and inner core is made up of highly cobalt and iron bearing minerals. Okay, these are the different zones have different mineralogy. Okay, then now go ahead. The geothermal gradient. Geothermal gradient means we already discussed about the density of the earth material increases with the depth of the earth. Means the crustal composition material is less denser than the mantle, and mantle material is less denser than the core. Means the core material, the gravity means the density of the core material is more than the mantle and crust. Already I have shown the diagram about velocity and density of the earth increases with the depth of the earth. Okay, now we go ahead. The temperature temperature and pressure, geothermal gradient. What is meant by geotherm? Geotherm means in such a way the pressure and temperature profile. In such a way, pressure and temperature profile of the earth is constructed. This profile is called as geothermal. Geothermal means those in such a way pressure and temperature profile of the earth is constructed on a diagrammatic representation. This profile is called as geothermal, and it is also called as geothermal gradient. Since the earth is 94% of magnesium, ferrous, silica and oxygen. In earth total composition of the earth, average composition of the earth, 94% of these four elements are present in the earth, that is the silica, oxygen, iron and magnesium. 94% of these minerals are found in the earth, other only 6%. Then the mineralogy of earth can be studied by examining the phases into which these elements combine along with the condition of geothermal. Okay, this diagram shows a temperature and pressure, temperature versus pressure presence in the earth. The temperature, suppose where the temperature 0 to 100 degrees Celsius, the pressure is 0 gigapascal, and when temperature rises from 1000 to 2000, then pressure also increases. The pressure up to the 10 gigapascal. Okay, then again, if temperature between 2000 to 3000, the pressure also increases up to the 125 GPa. Okay, then the temperature increases 3000 to 4000, and pressure also increases up to the 150 GPa. Okay, and when temperature cross the 4000 up to the 5000 Kelvin, not a Celsius, Kelvin, the pressure also increases from 150 to near about 300 GPa. Okay, GPa. And when the temperature crosses the 5000 Kelvin, the also pressure crosses the 350 gigapascal. Okay, the estimate pressure in the earth as function of the depth is accurate. The estimate of the temperature profile of the earth is very poor. Error may be higher than the 500 Kelvin when estimating the temperature, core temperature. Sadly, we do not really even know the size of the error, size of the particular zone. What is meant by GPa? GPa means gigapascal. The 1 gigapascal equal to 10 kilogram. The gigapascal is the conventional unit of the pressure when discussing the deep earth. 1 kilogram means 1 GPa is equal to 1 gigapascal, and 1 gigapascal equal to the 10 kilobar, and 1 kilobar is equal to the 1000 bar, means 1000 atmosphere of pressure. 1 kilobar equal to the 1000 bar and 1 gigapascal is equal to 10 kilobar. Okay, for our purpose, 1 atmosphere is the pressure of air at the surface of the earth. This pressure also commonly given in unit of bar, millibar, 1000 millibar. We measure the atmospheric pressure based on the millibar. Suppose when in monsoon period we measure the atmospheric pressure in millibar, somewhere 1000 millibar, 1100 millibar, so and so. I mean 1 kilobar is equal to the 1000 bar and 1 gigapascal equal to the 10 kilobar. From the surface to the transition zones and lower mental boundary near up to the 670 km depth, we can estimate the pressure by the simple rule thumb, that is 30 km depth change in close is 1 gigapascal pressure change. Okay, the core consisting of two distinct regions, inner core and outer core. Okay, inner core it is solid and outer core it is a liquid. Okay, outer core means outer portion of the core is totally made up of the liquidous material, hence it is called as highly viscous molten type of magma, molten type of material present in the outer core of the earth, and inner core is mostly made up of solidous material. We know this by examining the velocity profile. Shear waves do not propagate in the outer core. Why not? Why not shear waves are passing from the outer core? Because of shear waves means secondary wave. There are two types of wave present. Two types of waves are found as seismic wave, primary wave and secondary wave. Primary wave is also called as primary wave and secondary wave. Okay, primary wave are passing from all media, solid, liquid and gases, but secondary wave means shear waves are not passing from the liquidous material, and our outer core, our mother earth outer core is mostly made up of liquidous material. Therefore shear waves are not passing from this outer core. Okay, and that's reason the phase diagram of the iron, in general the phase diagram, that's reason we identify the internal structure of the earth based on the seismic wave. P means primary wave and S means secondary wave. Secondary wave is also called as shear wave, and these shear waves are not passing from the liquidous material. Means secondary wave are only passing from the solid or gaseous content. Okay, means the seismic importance of seismic wave, it is the identification of the internal structure of the earth. Based on the seismic waves, we are possible to identify the different layers of the earth. It depends upon the velocity of the passing of the different seismic waves from the crust, mantle and core. Okay, the phase diagram of the iron is well known as 20 gigapascal at 2000 Kelvin. Why not higher? We observe that there are several phases of iron in this region. Okay, at room condition, iron adopts BCC packing. Okay, and it is called as phase. With increasing temperature, it transforms to FCC G phase and then back to the BCC D phase. Okay, and finally to a liquid. With increasing pressure, iron adopts SCP structure E phase. Okay, E phase. You see this diagram. Okay. This is the final table of the different regions have different pressure and temperature. Our crust is our earth is made up of three layers: crust and mantle and core. We just see details about the core. The core started at 2571 km and end at 6371 km at the center. When the boundary between mantle and core at 2571 km, that region the pressure is about 117 gigapascal and the temperature is 3018 Kelvin. When after 200 km the pressure increases 10 gigapascal from 170 to 127 and temperature increases about 500 Kelvin, means up to the 3564 km. Then afterwards at 2891 km the pressure is about 135 gigapascal and temperature is about 3750 Kelvin. Increases depth, the pressure and temperature also increases. You see, at 3471 the pressure 206 and temperature 4260 Kelvin. At 3971 km the pressure 243 gigapascal and temperature 4500 Kelvin. At 4371 km pressure 277 gigapascal and temperature 4693 Kelvin, and at 4771 km the pressure is also increases up to the 306 gigapascal and temperature also increases up to the 4846 Kelvin, and at 5150 means at the boundary between the inner core and outer core the pressure is 329 gigapascal and pressure is 4961 Kelvin, and at the center of the earth the pressure is about 364 gigapascal and temperature is about 5151 Kelvin. Okay. The phase diagram does not match the geothermal data at the inner and outer core boundary. Why not match? Because of the nature of the solid inner core. The inner core is solidus and outer core is liquidus. Right now we think that the FCP E phase is correct. The structure type affects the physical property of the earth material. If the structure were cubic, then none of the property would have directional dependency. If hexagonal, then the value of given property is the same if measured in any direction parallel to the monolayer, but it differs in the direction perpendicular to the plane, that is A equal to B raised to 1 into C. Okay. These are the diagram. You do not need to this diagram. This is the model. This leads to model that inner core of the earth is one of the large SCP single crystal. The direction of the magnetic flux is parallel to the C-axis. Furthermore, a closest packing structure can be slipped easily in direction parallel to the monolayers. This may account for this change in the direction of the earth magnetic pole. Okay, so this is the dipole equator. Okay. This is another model about steel. One of the reasons that pressure and temperature condition measured for iron do not seem to match the observed core condition is that the core is not pure of iron but contains cobalt and nickel and maybe other elements such as oxygen, silicon, hydrogen in little amount. This is largely uneducated guys, but we can learn a lot by studying the effect of impurities in the iron structure. A good example of this phase diagram of steel, the greatest interest in iron, its industrial use as the major component of steel. Steel is a mixture of iron and carbon. It is complicated by A to G phase transition at 900 degrees Celsius. Only the phase is ferromagnetic. The G phase is the non-magnetic, called as austenite. It contains up to the 7 carbon atoms and 100 iron atoms approximately. Fe14 carbon, any more than this, and carbon does not mix into the iron structure instead of nucleus and forms inclusion of graphite. Okay, carbon mixed into the GFE structure extend the field GFE and forms inclusion of graphite. Carbon mixed into the GFE structure extend the field of GFE down to 700 degrees Celsius and temperature below the 700 degrees Celsius, the structures break down into the ferrite. Now phase no carbon plus cementite F3 carbon. Cementine is soft and break easily. Cementite mineral is very soft and break easily. It is also called as pig iron. When it is heated, it goes to the graphite plus GFE. You should see this diagram. This is ferrite plus perlite, then form cementite pearl plus perlite. The carbon percentage from 0 to 5, and here the temperature 600 to 1400 degrees Celsius. This is the liquidus curve, where the presence of Fe3C plus liquid, then Y plus liquid. This is the austenite region. This is the liquidus curve of ferrite and perlite, and then form austenite plus cementine, and after 1000 degrees Celsius, these austenite and cementine converted into the austenite. This is the liquidus curve, and here the total liquid. This is the different layer of the earth, chemical mineralogical classification of the different layer of the earth, as well as geothermal gradient means temperature and pressure are present at different layers of the earth. Okay.